In this lesson, we're going to be looking at the product and the quotient rule. Let's take a look at if we wanted to find the derivative of f of x times g of x. Does that equal, well, can I take the derivative of the first function, take the derivative of the second function, and then just multiply them together? That's what we're going to explore. Let's look at 3x squared minus 1 times x cubed. We're going to take the derivative of each one of those separately. So the derivative of 3x squared minus 1, we would get 6x, and the derivative of x cubed is 3x squared. So if we multiply those together, we would get 18x cubed. Let's approach this a different way. What if we multiplied those two together first? So if we multiplied 3x squared minus 1 times x cubed, we would get 3x to the fifth minus x cubed. Now we know taking the derivative of 3x to the fifth minus x cubed, we can take the derivative of each one of these separately because we are subtracting them, not multiplying them. So we know to find the derivative, we would get 15x to the fourth minus 3x squared. We know that is correct. Now if we compare that to what we got in the first way we tried it, we can say these are not equal. Therefore, 18x cubed is not the correct derivative of our f of x times g of x. So let's go back up and say these are not equivalent. So there must be some special rule that we need to learn if we want to find the derivative of an f of x times a g of x, and we can't multiply them together like we did in this problem. We're going to look at trying to prove what does the derivative of f of x times g of x equal. Now if we looked at this rectangle, we could say if we have the length of this rectangle equals our g and the height of the rectangle equals f, the area of this rectangle would represent our f times g. Now we're going to take small changes in f and g, and we'll call those delta x. So if x changes by an amount delta x, then the corresponding changes in f and g are, we can see we have delta f, the change in f, would be f of x plus delta x minus f of x. That would be the change in f. Likewise, the change in g would be g of x plus delta x minus g of x. That would give us just simply the change in g. If we multiplied the change in f times the change in g, we would be multiplying f plus the change in f times g plus the change in g. And so we're representing this now with our rectangle. These new colored areas we would get from multiplying this all out. Now we're just going to multiply these two quantities together. So the change in f of g of x. Now if you take a look at, here we would have, if we multiplied this quantity out right here, we would have f times g plus f times delta g plus g times delta f plus delta f times delta g. Now, the reason we're subtracting off f of g is we simply want the change in f times g. So to represent just the change in f times g, which is our colored areas, we would need to subtract off f times g. And here we would be left, now you can see f times the change in g is here, plus g times the change in f is here, and the change in g times the change of f here. So that represents our change in f times g. So this represents our change in f times g, our colored areas. Now we're going to divide everything by the change in x. So if we divided everything by the change in x, we get this. Now this is looking awfully close to, if you take a look at these up here, this looks like it's almost the derivative of f times g. If we took the limit as delta x goes to 0, we would have that derivative. The same for this right here. If we took the limit as delta x goes to 0, that's the definition of g prime. Likewise here, if we took the limit as delta x goes to 0, that's the definition of f prime, or the derivative of f. And likewise here. Now notice this delta f is not being divided by delta x. So that is not going to be the derivative of f. So let's take the limit as delta x goes to 0, and that would give us the derivative of f times g. And then if we do the same on the right side, and we know our properties of limits, we could take the limit of each one of these terms separately. Here we have, this is just g prime. So we would have f times g prime plus g times, well, this would just be the derivative of f. So this would be our f prime. Now what happens to the limit of delta f as delta x goes to 0? Well, if we look back over here at delta f, as delta x goes to 0, well, delta f is going to go to 0. So this quantity would go to 0. So we would have 0 times this quantity. So this entire term goes to 0. So what we're left with is the rule, it's called the product rule. We have found now the derivative of f times g. So the product rule is, if we want to find the derivative of an f of x times a g of x, we take the first function times the derivative of the second function plus the second function times the derivative of the first function. That's the rule. Now, I like to just say the first times the derivative of the second plus the second times the derivative of the first, but can you see with this, since the first term is being multiplied, we could switch those two and say g of x times, the derivative of g of x times f of x. We could switch the last term and say f of x times the derivative of f of x times g of x. And also we could switch the terms because multiplication and addition are commutative. So you'll hear some people say it the opposite way that I do, but that's fine. I like to say the first times the derivative of the second plus the second times the derivative of the first. Some people like to say the second times the derivative of the first, and so on. But realize it's okay because it's commutative. This is just what I say to remember the product rule. So differentiate the square root of x times e to the x. So you can see we have an f of x times our g of x. If we identified the f of x, we would say I'm going to say since our function is f of x, I'm going to say we have an h of x times a g of x. So we would say our h of x is the square root of x times our g of x. Well, g of x would be e to the x. So we can apply the product rule. So applying the product rule, we would take the first times the derivative of the second function plus the second function times the derivative of the first function. Now the derivative of e to the x we know is just e to the x. The derivative of the square root of x, I changed it into x to the 1/2. Now we can apply the power rule. So now we can replace the derivative of the square root of x with 1 divided by 2 times the square root of x. That's our derivative. Now we could simplify this a little bit. We could factor out an e to the x, and then we could get a common denominator. But this is the derivative of our function. Another function. So we have x times e to the x. So we're going to apply the product rule. So we'd have the first function, which is x, times the derivative of the second function, which is e to the x, plus the second function times the derivative of the first. We know the derivative of e to the x is e to the x. The derivative of x is just 1. So we have our derivative. And again, we could factor out an e to the x. So we would have an e to the x times x plus 1. That is our derivative. And here's the graph of the function and its derivative. Here we have another function, the square root of t times 1 minus t. So it's asking us to find the derivative. So we could apply the product rule. First times the derivative of the second plus the second times the derivative of the first. So the derivative of 1 minus t is just -1. The derivative of the square root of t, think back a couple of slides, we looked at the derivative of the square root of x. We got 1 divided by 2 square roots of, and our variable here is t. So that is our derivative. Now we could clean this up a little bit. And we get 1 minus 3t divided by 2 times the square root of t. And there's the function, the graph of the function, and the graph of the derivative function. Now, there's one thing I want to show you on this particular problem. We could have approached this problem differently. We could have rewrite this as the square root of t minus the square root of t times t. This is t to the 1/2 minus. Now the square root of t is just t to the 1/2. And if we have t times the square root of t. We have like bases, and we can add the exponents. So we'd have t to the 1/2 minus t to the 3/2. Now we can just apply the power rule. We don't have to use the product rule. So we'd get 1/2 t to the negative 1/2 minus, bring down our exponent, and then subtract 1 from our exponent. And there's our derivative. And if you cleaned this up a little bit, you would see we could make it look like what we have from when we used the product rule. Okay, so you could make this look like what we had using the product rule. Sometimes you want to look for that. You want to look to see if you can simplify your function before you find the derivative. Because if you can, many times it's much easier the way I did it here, not having to use the product rule, but just using the power rule. So we have f of x equals the square root of x times g of x, where g of 4 equals 2, g prime of 4 equals 3. Find f prime of 4. Well, thinking about this problem, we had to find f prime of 4. So if we have to find f prime of 4, I would be thinking, well, I need to find f prime of x first, because then if I find f prime of x, I could then find f prime of 4. So let's see if we can find f prime of x. So we would have to use the product rule. So we have the first times the derivative of the second plus the second times the derivative of the first. And this right here is just g prime of x. So we could plug in 4 because we're looking for when x equals 4. So we're finding f prime of 4 now. So for all the x's, we just plug in 4. So the square root of 4 times the derivative of g of 4, which we know is g prime of 4. And we can see that was given as 3. And then we have plus g of 4. Well, that was given. That's equal to 2. And then 1 all over 2 times the square root of 4. So we should be able to find the value of f prime of 4. So filling in the given information. And our g of 4 we said would equal 2. So we're going to plug that in. And now we can simplify. And we get f prime of 4 equals 6.5. Now we're going to look at the quotient rule. Just as with two functions being multiplied together, we had a special rule to find the derivative. If we are dividing two functions, there is a special rule that we have to use. And that is called the quotient rule. So if we're looking for the derivative of an f of x divided by g of x, this is our rule. We have to take, now I'm reading in the numerator, the bottom function times the derivative of the top function minus the top times the derivative of the bottom all over the bottom squared. And again, that's just how I say it to remember. I say the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now we do have to be careful with this one. We can't switch the numerator around because subtraction is not commutative. So we have to put it in this order. Now you will hear some people use a different technique to remember this. they consider f of x the high function because it's in the numerator, and they say, well, g of x is the low function. So you'll hear some people say low d high. This would be low, and the d is for derivative. Low d high minus high d low all over low squared. So if you hear somebody saying low d high minus high d low all over low squared, you know they are applying the quotient rule. Whatever you need to do to commit this to memory. All right, so let me erase all the ink. So this is just how I say it. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So it says let y equal x squared plus x minus 2 divided by x cubed plus 6. Find y prime. Okay, so we need to find the derivative. Here, it doesn't appear that we can simplify this function, so we're just going to go ahead and apply the quotient rule. So applying the quotient rule, we'd have the bottom times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. Now in the numerator, the derivative of x squared plus x minus 2 is 2x plus 1, and the derivative of x cubed plus 6 is 3x squared. So now we're going to simplify this. We just multiply, and then we're going to try to combine any like terms, and there is our derivative. Find an equation of the tangent line to the curve e to the x divided by 1 plus x squared at the point 1 comma e over 2. So to find the equation of a tangent line, we need to find the slope of that tangent line. So we need to find the slope of the tangent line at x equals 1. So we're going to need to find the derivative of our function so we can find the slope of the tangent line when x equals 1. And it appears we're going to have to apply the quotient rule. So we'd have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So we're simplifying it, and there's our derivative. Now we're trying to find the slope of the tangent line when x equals 1. So now we can plug in 1 for x. And when we plug in 1 for x, you can see we'd get 1 minus 1 squared in the numerator. So we would get 0 all over 1 plus 1, which is 2 squared. So we'd get 0 over 4. So this quantity here equals 0 over 4. So the slope of the tangent line would be 0. So we have the slope of our tangent line. If we now used y equals mx plus b to find the equation of the tangent line, we have our slope, and to solve for b, we could now plug in the 0.1 e over 2. So y is e over 2. This is 0. So we have b equals e over 2. So the equation of the line would be y equals e divided by 2. And that's the equation of the line we see here. And looking at when x equals 1, right here, we can see
It's tangent to the curve. The curve comes up here like this and like this. So you can see the slope of the tangent line is 0 right there. It's the red line. So remember, try to rewrite the expression to a simpler form before differentiating. In this example, your first thought may be, we've got to use the quotient rule, but can we simplify this before we find the derivative? We could rewrite this as 2x cubed divided by x minus the square root of x divided by x, which is equivalent to 2x squared minus, now this is x to the 1/2 all over x, which would be 2x squared minus x to the negative 1/2. Now we could just apply the power rule to find the derivative. We don't have to use the quotient rule.